What's up everybody and welcome to a new video. In the previous video we finished the game mechanics, and now in this video we're going to work on the AI opponent. And here I also have a side note, namely in game development the computer opponent is usually called AI, even if it actually doesn't have anything to do with artificial intelligence. So that's why I call it here AI, even though it doesn't have anything to do with artificial intelligence, but instead it's just some basic rules here. Okay, so that being said, the simplest way to create an AI opponent is to create a random AI opponent. So therefore, let's write the code where the AI simply plays a random column. So therefore, we're going to create another helper function. So let's make here a comment, and these are going to be the AI functions. And let's call this function choose column AI. And then here we're going to first create a variable called columns, and it's going to be a list where you put in all the columns that the AI can play. So we're going to put in here a 0, 1, 2, 3, 4, 5, and 6. And now to make this AI a little bit better, what we're going to do is we're going to prioritize those inner columns here. And that's because if you play one of those inner columns, then you just have more opportunities to connect 4 dots. So therefore then here we're going to put in the 2 twice, the 3 and the 4. So this way then we have here a 60% chance of picking one of those inner columns and only a 40% chance of picking one of those outer columns. So then here let's add a comment. So we're going to say that these are the columns that the AI can play, and now we simply want to randomly pick one of those columns here. So therefore we're going to need the random module. So we're going to say here at the beginning import random, and then here let me just say that these are then the game functions. And then in our choose column AI function, what we want to do is here simply return random dot choice, and then here we put in the columns. So this is now our helper function. So now we need to adjust here our game.py file. And the first thing that we need to adjust is that we need to be able to switch between the different player modes. So one player mode against the AI or 2 player mode against the human. So therefore we're going to create another variable, and we're going to call this playing mode. And it's going to be the result of this input here. And the prompt is going to be the following. So here we're going to ask, do you want to play 1 player mode or 2 player mode? And then enter here a 1 or 2. So that's the first thing that we need to change. And then here, when we choose a column, we have to distinguish between when the AI chooses a column versus when the human chooses a column. So therefore then we're going to say if playing mode equals 1. So if you're playing against the AI, and then we also have to add another condition, namely we have to check if the current player here is the AI. And we're going to say that the AI is always going to be here player O, so the second player in this list. So definitely we're going to say and current player is equal to hf dot players, and then brackets 1 to get here this O. So if that's the case, then the AI should pick a column. So then we're going to say column equals hf dot choose column AI. And if that's not the case, then the human has to pick a column. So therefore then what we're going to do is we're going to indent all of this code here into this else block. And then just to make the game just look a little bit nicer, here I'm going to insert the print statement that says the AI is choosing a column. And then I would like the program to wait for a short amount of time. So therefore I'm going to import here the time module. So I'm going to say import time. And then here we're going to say time.sleep. And then we're going to wait for half a second. So that's the code. So now let's see if that is working. So let's run the file. So we are asked if you want to play 1 player mode or 2 player mode. So let's pick 1 player mode. So now let's here choose column 4. And now the AI picked also column 4. So now let's simply pick column 3. Now it picked column 5. So now let's pick column 2 And now we can make a win in column 1. So now player X has won. Do we want to play again? No. And as you can see, our code is working. So therefore then we can here check off the first point in our to-do list. Then the next point in our list is that we don't want the AI to play a full column. So currently the AI simply randomly picks one of those columns here. And if one of those columns happens to be full, then that will break our game. So to demonstrate that, I've prepared here this grid. So here all the columns are full except here column 4. So now let's see what happens if we play this game. So we're going to click one player mode and then play column 4. And then here, as you can see, we get here an error and it says type error, namely the non-type object is not iterable when we call here this hf.show function. So what's happening is the following. So the AI here is choosing a column that is full. And then here, when we want to execute the move and call this make move function, what happens is that in this make move function here, this if statement is never triggered because there's not an empty cell in the respective column. So therefore then this make move function returns a none. So therefore then here this grid here is none, and then we pass in here a none into this show function and then get this error. So to get around this, what I would like to do is to remove all the columns that are full from this columns variable here. So therefore we're going to create here another comment. So we're going to say remove full columns. And we're going to do that by using a list comprehension. So to show how that works, I'm going to use here this Jupyter notebook. And here we also have this grid and this columns variable. And now let's create here a list comprehension. So here we're going to say for C in columns. And then here we want to have C, but only if the respective column is not full. And therefore we can use here this is column full function. So we're going to say if not hf dot is column full, and then here we have to pass in the grid and the column. So we're going to say here grid comma C. So now if I run this, then we should get a list that only contains here those two threes. So let's see if that's the case. So let's run it, and as you can see, we only have here those threes. So our function here is working. So let's copy this into our choose column AI function. So here then we're going to say columns equals this list comprehension. And then here we don't need this hf anymore. And then here, as you can see, we actually need here to pass the grid into this function. So therefore then here in our game.py file, we also have to pass in here the grid into choose column AI. So now let's see if this code now is working. So let's run the game again. One player mode, and we're going to play column 4. And as you can see, the AI now played column 4. So let's just play it again to see if that's still working. And it played column 4 again, and now a last time. And again, it played column 4. And we have here a draw. So let's say then here no. So then, as you can see, our code is working. And we therefore then can check off here the next point in our to-do list. Then the next point in our list is that we want the AI to make a winning move. So for example, if we have a grid like this here, so let me copy and paste that. Then in this case, we don't want the AI to simply randomly select one of those columns, but instead it should play either column 2 or column 6. And there are different ways in which we could go about achieving that. So one way could be to do something similar like we did here with this is4 connected function. So we could create something where we check if there are 3 dots connected and then make the respective move. However, we can also do it much more simpler. Namely, we can so to say simulate the move. So we can create here a copy of this grid, then make a move here on column 1, and then check if there are 4 dots connected or not. If that's not the case, then that's not a winning move. And then we go to column 2, again, make a move or simulate a move, and then check if there are 4 dots connected. And in this case, there would be 4 dots connected. So then playing 2 here would be a winning move. So that's what we're going to do. So therefore, we're going to create here another helper function, and we're going to call this simulate moves. And here we pass in the grid. Then we pass in the player for which we are going to simulate the moves. And then lastly, we're also going to put in here the columns. And then here at the beginning of the function, we're going to create a variable called moves. which is simply an empty list. So to this list, then we're going to append all the columns that are winning moves. So then next we're going to loop over all the columns here. So we're going to say for column in columns. And here we can actually transform these columns into a set so that we only have unique values. So that way then we don't simulate the moves here for column 3 twice, for example. So then next within this for loop, what we're going to do is we're going to create here a copy of our grid. So we're going to say grid underscore copy. And therefore then we need the copy module because we're going to, because we want to create a deep copy. So we're going to say import copy. So then we create here a deep copy of our grid. So we're going to say copy.deep copy of our grid. Then next we want to make a move on this grid copy. So we're going to say grid copy equals make move. And then here we have to specify the grid, the player and the column. So we're going to pass in our grid copy, then the player, and then lastly the column here from this for loop. And then next we want to check if then after this move there are four dots connected. So we're going to say if is for connected on our grid copy. Then if that's the case, then we want to append the respective column here to our moves. So we're going to say moves dot append, and then we want to append the column. And then lastly, we simply want to return our moves. So if there are no winning moves, then the function would simply return here an empty list. So now let's test if this function is working. So therefore I've prepared here this notebook. So here then let's say hf.simulate moves, and we're going to pass in the grid. Then the player is going to be player O because that's the AI. And then we pass in here our columns. So in this case, then it should return now a list that contains here index 1 for column 2 and index 5 for column 6. So let's see if that's the case. And as you can see, we get here a list containing 1 and 5. So our code is working. So now let's use this simulate moves function in our choose column AI function. So therefore, we're going to create here another comment, and we're going to check if there are winning moves for the AI. So then we're going to create here a variable called winning moves, and then we're going to call the simulate moves function. So then we pass in the grid, and then for the player we're going to pass in the AI. So we're going to create another variable. So let's call this here AI, and it's going to be equal to players brackets 1. So this way then we get here the second element in this list, so which is then O, which we said is the AI. So then we're going to pass in here the AI. And then lastly, we're also going to pass in the columns. And then next, we're going to check if there are winning moves. And if there are winning moves, then we want to return one of those winning moves. So then here we're going to say again, random.choice of our winning moves. So that's our code now. So now let's see if that is working. So let's open the terminal again and then run the game. One player mode. And then here, let's play column 4. And then after that, the AI should either play column 2 or column 6. So let's see what happens. And as you can see, it now played column 6 and player 01. And then here, let's say no. And now let's just run the game again, just to test it again. So let's here play again column 4. And again, it played here column 2. So now let's just do it for a third time. Maybe it then plays column 2. So one player mode and then column 4, and this time it played column 2. So as you can see, our code is working, and therefore then we can check off here the next point in our to-do list. Then the next point in our list is that we want the AI to make a defending move. So for example, if we have here a grid like this, then again, we don't want the AI to randomly play any column, but instead it should play either column 1 or column 7. So now let's implement that. and it's actually pretty easy to do. So we only need to copy here this block of code. And then here we're going to say if there are defending moves against the human. So we're going to say here against the human. Then instead of passing in the AI, we're going to pass in the human. So therefore we're going to create another variable. So let's call this human, and it's going to be equal to players brackets 0. So that's going to be the X then. So let's pass in this human. And then here, instead of calling these winning moves, we simply call them defending moves. And that's already it. So now let's test if that is working. So let's run the game again. Then we're going to choose one player mode. So here we're going to play column 4. And then the AI should either play column 1 or column 7. So let's play column 4 here. And then here, as you can see, it played column 7. So let's again play column 4. And then it should play here column 1. So let's see if that's the case. And again, it plays here column 1. And now let's again play column 4. And then after that, it should also play then here column 4 to again make this defending move. So let's run it. And as you can see, it again plays here column 4 to make this defending move. So our code is working. So therefore then we can check off here the next point in our to-do list. Then the next point in our list is that we don't want the AI to block subsequent winning moves. So to show what I mean by that, I've prepared here this grid. So here there are 3 O's connected. So therefore then the AI shouldn't either play column 1 or column 5. And that's because otherwise player X could then in the next move here block the subsequent winning moves. So that's what we now want to implement. So therefore let's copy here this comment. And then going to paste it. And here we're going to say check if there are subsequent winning moves. So in order to achieve that, we have to modify our simulate moves function. So what we want to do here is we want to add some functionality that allows us to make a 2-move simulation. So therefore we're going to add here a parameter, and we're going to call that 2moves. And we're going to set a default value for that. And we're going to set that to false. This way then we don't have to modify our function calls here. So then one thing that you might want to do here in this function is to say if 2moves is true, then we want to run this line here simply twice. So we want to run the make move function twice. However, there's a problem with that. Namely, if we already have here 2 O's like we have here in column 7, then if we would make here 2 moves, so if you would add here an O here and there, then there would be 4 O's connected. So therefore then this if statement here would be true, and that's not what we want. What we actually want is to actually only make here this second move. So therefore then we have to modify our make move function. So therefore then let's just simply pass through here this 2moves parameter. And now let's go to the make move function. And here we're also going to create a new parameter, which is this 2moves parameter. And we're also going to set that equal to false. And then here where we make our move, what we're going to say is if 2 moves, then we want to make our 2-move simulation. So what we want to do is instead of making the move here, we want to go 1 row up and then make our move here. So in order to achieve that, what we're going to say is simply here grid and then row minus 1. So this way then we go simply 1 row up. However, we obviously can't do that for this top row here. So therefore we're going to add here another if statement. And we say that we're only going to do that if row is not equal to 0. So only then we're going to make this 2-move simulation. And otherwise, if 2 moves is false, then we're simply going to make the move as we did before. Okay, so that's the change that we had to make to our make move function. So now let's test if this simulate moves function here works for this grid. So therefore, I prepared this in this notebook here. So here's the grid. Here are then the columns, and here I filtered out all the full columns. So now let's call this simulate moves function. So we're going to say hf.simulate moves. We're going to put in the grid, and the player is going to be player O. And then we put in here the columns, and then lastly we're going to set the 2moves parameter equal to true. So now in this case then this function should now return a list containing a 0 and then here a 4. So let's see if that's the case. So let's run this. And as you can see, it returns here 0 and a 4, and our code is therefore working. So the simulate moves function is working. So now let's use this here in our choose column AI function. So therefore then here we're going to create a new variable called subsequent winning moves. And here we're going to call this simulate moves function, put in the grid, the AI, the columns, and we're going to set the two moves parameter equal to true. So this way then we have created the subsequent winning moves, and now we have to remove them from this columns variable. And that's because if there are no winning moves, or if there are no defending moves, then we actually first want to play one of the columns from this columns variable and not one of the columns from the subsequent moves variable. So therefore, let's now adjust here this comment. So we're going to say, check if there are subsequent winning moves, and if there are, then remove them from columns. So let's now remove them. So we're going to say columns equals, and then here we're going to again use a list comprehension. So we're going to say for C in columns. And then here we simply want to have C. However, we only want to have that if C is not in subsequent winning moves. So then once we filter them out, what we're going to say here is if columns. So if this list here is not empty yet, so it could be empty if all the columns are full, or if there are only subsequent winning moves left. So if we still have some columns left to play, then we want to play them. Otherwise, what we're going to do is we're going to pick one column from the subsequent winning moves variable. So we're going to then say, otherwise return random.choice from subsequent winning moves. So that's now our code. So now let's see if that is working. So let's run here the file again. So let's play one player mode. So now what I'm going to do is I'm only going to play column 6 and 7, and the AI should also play only columns 6 and 7. So now let's play here column 7. And then as you can see, the AI played column 6. So let's play 7 again. And then now the AI played 7. So now let's play 7, and then the AI can only play column 6. So now let's play column 6. And now lastly, when I now play column 6, then the AI has to play either column 1 or 5. So let's see if that's the case. And now I've played it, and it played here now column 1. And now I could block here this subsequent winning move. So as you can see, our code is working. So therefore then we can check off here the next point in our to-do list. And then the last point in our to-do list is that we don't want the AI to enable subsequent losing moves. And again, to show you what I mean by that, I've prepared a grid. So here there are 3 axes connected. So therefore then the AI shouldn't either play column 1 or column 5, because otherwise player X could then win here in the next move. So in order to implement that, we can simply copy here this block of code. And then here we're going to say, check if there are subsequent losing moves for the AI. And then here, this variable, instead of calling it subsequent winning moves, we're going to call it subsequent losing moves. And then here in this function call, we put in simply the human and not the AI. And then here at the end, what we're going to say is, if there are some subsequent winning moves, then we want to play one of those. Otherwise, we then have to play one of the subsequent losing moves. So then we're going to say return random.choice and then subsequent losing moves. So that are already all the changes. So now let's see if that is working. So let's run the game again, one player mode. And again, now I'm just going to play columns 6 and 7, and the AI should also do that. So let's play here column 6. And then the AI also played column 6. So let's play it again. Then it played again column 6. So now let's again play column 6. and then it played 7. And now lastly, when I play column 7, the AI has to play either column 1 or column 5. So let's see if that's the case, if that works. And as you can see, it played here column 5, and now we can make here the subsequent losing move for the AI. So we're going to play column 5, and then X has 1. So as you can see, our code is working. And with that, then we can check off here this last point in our to-do list, and therefore then we have checked off all the points for this AI opponent section. So we've reached the end of this video, and then in the next video we're gonna work on the game aesthetics. So thanks for watching, and hopefully I will see you in the next video.